Hello friends, I welcome you in the video lecture on Optimum Design Part 1. First we'll see the introduction. First we'll see what is meant by optimization techniques. The optimization techniques provide the tools for selecting the best design solution from all the available feasible solutions. So basically it is the technique which will help us to select the best solution from the available number of available solutions to a single design problem. And then what is meant by optimum design? An optimum design is the best attainable solution to the design problem within the given constraints. So this means that by using this optimization technique, we have to select a single best solution from all the available solutions. And the solutions that we select is the best solution, and that solution is called as optimum design. So that means an optimum design is the best solution to the design problem within the given constraints. So this is the best solution selected from all the available solutions is called as optimum design. Then we'll see how this optimum design are different from normal design. The normal design problem look like this. A cantilever beam of cross section, circular cross section and length 200 mm is subjected to a force of 5 kN at the end. The factor of safety based on the tensile yield strength is 1.5. Design the beam if the material of the beam is steel with yield strength SYT is equal to 400 Newton per mm square. So basically this is a normal design problem in which we have to design the cantilever beam which is subjected to force of 5 kN at free end. Factor of safety is given and SYT is given. So this is a straightforward problem where we have to find out the cross section of this cantilever beam. So by using the bending stress equation, we can find out this cross section, that is diameter of cross section of this cantilever beam by using this SYT and this Fs. So here we have only one option for the material. So this is a straightforward problem. We don't have multiple solutions. So we have only one solution with single value of SYT. And with that single value of SYT, we have to find out the diameter of cantilever beam. But look at the optimum design problem, how it is different from normal design. Now in this optimum design problem, we have to design cantilever beam of circular cross section length 200 mm is subjected to a force of 5 kN at the end. Factor of safety based on the tensile yield strength is 1.5. Design the beam with objective of minimizing the material cost out of the following materials. So this table is given. So in this column wise we have material mass density, material cost per mass, that is per kg, and yield strength. We have three different materials: steel, aluminum alloy and magnesium alloy. And for this all three materials we have the mass density, material cost per kg and yield strength. So if you compare these two problems, in this normal design problem we have only one material and hence single value of SYT. But here optimum design problem we have three materials. As here there is one material, that means we have only one solution, one possible solution. As here three materials are given, so here hence three possible solutions are available. And this normal design problem is without objective. So there is no any particular objective while designing the machine element. But if you observe this design problem has objective for minimizing the material cost. So this means here just we don't have to just design the cantilever beam, but also we have to design it for the minimum material cost. So this is the objective of this design. Design the cantilever beam such that it should have the minimum material cost, and this is way the optimum design problem is different from normal design problem. So here in optimum design problem we have three possible solutions, and by using the optimum design technique we have to select one best possible solution which will have the minimum material cost, and that solution we call it as a optimum design for this design problem. So this is the way this normal design problem and optimum design problem is differs. And to solve this optimum design problem, we are going to study one method that is called as Johnson's method of optimum design in the next part of video lecture. Now let us switch to the next part. So now we'll study the classification of design parameters. Now in the optimum design, many times this word is used, design parameters, and there are different types of design parameters. So let us look at the classification of design parameters. So first one is the functional requirement parameters, and these functional requirement parameters also include the undesirable effects. Next we have material parameters, and third we have geometrical parameters. So in the next part we'll see one by one what is meant by these functional requirement parameters, why it is said including the undesirable effects, what is material parameters, and what is geometrical parameters. So first one is the functional requirement parameters including undesirable effect. The functional requirements are the conditions which must be satisfied by mechanical elements. So these are the conditions. Functional requirements parameters are nothing but the conditions which must be satisfied by a mechanical element that we are designing. For example, for a gear pair, if you are designing a gear pair as a mechanical element, then the functional requirement parameters would be power transmitting capacity and gear ratio. So while designing the gear pair, these parameters must be satisfied because these are the functional requirement parameters. Because the function of gear is to transmit the power with certain gear ratio. So that's why these two parameters are considered as a functional requirement parameters for gear pair. And if we designing gear pair, this parameter must be satisfied. Similarly, for a helical compression spring, the functional requirement parameters might be a maximum force exerted by the spring and the spring stiffness. So while designing the spring, these parameters must be satisfied if it is mentioned in the design problem. The functional requirement parameters, the functional requirement parameter group also includes another group of parameters known as undesirable effect parameters. All the mechanical elements have certain undesirable effects like cost, weight, stresses, deflection, and vibrations. If you look at these parameters, you will find that the power transmitting capacity and gear ratio, maximum force exerted by spring, and the spring stiffness are the parameters which may require to maximize. Many times we require to maximize these parameters. But if you look at this parameter, cost, weight, stresses, deflection, all these parameters we need to minimize. Cost we need to minimize, weight we need to minimize, stresses we need to minimize. That means undesirable parameters many times we need to minimize, and all these all these functional requirement parameters here mentioned in these two examples need to be maximized. So functional requirement parameters many times are maximized, and undesirable parameters we need to minimize. So material parameters, this is the second design parameter. The material parameters are those parameters which describe the material with values. For example, density, modulus of elasticity, modulus of rigidity, Poisson's ratio, yield strength, ultimate tensile strain, cost per unit weight are nothing but the material parameter, and material parameter describes the material with values. So all these parameters are will be mentioned with some particular values. So these are nothing but the parameters related to material, which describes material with values. Third one is the geometrical parameters. The geometrical parameters are those parameters which define the geometry of the mechanical elements. The example of geometrical parameters are module, number of teeth, face width, pressure angle, addendum, dedendum are the geometrical parameters for spur gears. If you consider example of shaft, then there would be diameter and length. If you consider a spring, there would be geometrical parameters would be its outer diameter, inner diameter, then wire diameter, pitch. These are some examples of geometrical parameters. So depending on the components, these geometrical parameters will change. So thanks for watching this video. If you have any query related to this video, you can mention in the comment section. Next part of this optimum design will cover in the next video lecture.